So hello everyone, my name is Fernando Villaça Meyer. I'm Director of Operations of Cordial Institute. We are an independent think and do tank that works with data science, territorial intelligence, and intersectoral articulation to strengthen networks and ground public and private decision-making on data and evidence based in Brazil. We work with special projects and articulation initiatives that are going to speak about a little bit today, and local engagement projects. So this study, Average Speeds and Road Safety in São Paulo, application of Uber Movements data, which we conducted last year in partnership with Uber, was done inside the Road Safety Panel initiative that we have for the past couple of years. So the Road Safety Panel initiative establishes intersectoral forums of discussion, articulating public and private organizations to deepen the debate on the relationships between traffic crashes and the design of urban streets. So our main goal is to be really close to the authorities and bring together all the other public and private organizations to discuss about this issue of road safety, to change the way they relate to each other, to be placed on data and data evidence and evidence-based decision-making. So we monitor patterns and trends in the way crash happens and seeking to contribute to foundation and direction of actions and interventions. So the Road Safety Panel initiative is being conducted in partnership with other organizations in the field, and with the São Paulo City Hall and the engineering traffic company of the city. So we do every year we do some workshops, intersectoral workshops, to raise hypotheses about road safety in the city. So we raised until now 141 hypotheses in workshops like this one. And these questions, they are really important for us because it shows us how these organizations are thinking about the issue in the matter of road safety. And our challenge is to help them make good decisions and make these decisions based on evidence. So questions like this one: when there is a bus lane on the left, there are fewer accidents, but more severe ones. And our question is that true? So to answer this kind of question, we have been gathering a really huge data warehouse and building databases of different kinds of attributes about the geometry and the characteristics of the streets. We don't have normally information about the behavior of the drivers, so it's a different approach from the last presentation. I think this is a really interesting thing to discuss. It would be really good to have the information about the behavior too. So I think here having more data is always helpful. So first of all, we identify the part of the streets where you have the intersection and the influence area using GIS algorithms, the block frontage, the intersection, the mid-block, which is complementary to the influence area, and we correct the position of the accidents. We have a public platform here in São Paulo where you have all the data about the crashes, the victims, the time and the place where each crash happened, which is really helpful. But we need to make some corrections because the geocoding is always a little bit mistaken. So this is the first thing that we do to do this kind of analysis. And we have plenty of other attributes about these places. So this is an intersection with a traffic light. So you have this block frontage, which is an avenue. And we gather this information with the information about the crash and the victims. But you have hypotheses like this one, where there's a traffic jam on the road, crashes are more frequent. And we don't have information. We don't have public data available about the speed of the vehicles on the place and time where each crash happened, much less if there was a traffic jam. So there was a couple of hypotheses that we could not answer with the data that was available with the public authority. So by pairing data, now we have this kind of information. So we have the information, the data from the Vida Segura platform, from the City Hall, the data from our databases and data warehouse from the Road Safety Panel Initiative about the geometry of the roads, and now the information, the data from Uber. So this study was conducted with this data from Uber movements. They have a layer which is called Speeds. Uber movement platform is a platform that delivers data from a lot of cities in the world, and Uber delivers that in an aggregated form, so is anonymized and is really helpful to do plenty of analysis. It's not raw data, so we are not dealing with streaming. We are not dealing with big data. We are dealing with something like touching the big data. And so to use this data, they provided with the paired with the OpenStreetMaps ways, segments, and relations too. So it was said in the last presentation too. It was really good to see that coming there. And we did the pairing with the OpenStreetMaps with our data on segments, and so we could do this relation about using the data from the victims, the accident, the crash, which is from the source of the Vida Segura platform, the data on the OpenStreetMap database, which is related to Uber movements data on speeds, and the infrastructure attributes from our Road Safety Panel Initiative database. So some concepts too before explaining and showing some results. Having this data now paired, we can identify the free flow speed, which is the 85th percentile of the all observed speeds on that specific segment of the road on 2018 observed speeds, which is our time frame of analysis. And traffic jam, we use this indicator from 0 to 25% of the free flow speed. We consider heavy traffic jam, and when you have 25 to 50% of the free flow speed, we have light traffic jam. So the study, we analyzed 572 million records of Uber movements average speed data. Here is interesting to say that it's important to say that we cannot cover all the city, but we cover almost all the city, because they aggregate the speed from at least 5 Uber drivers that passed in each segment of the road that hour. So the data was aggregated by hour and by segment of the street. But even though the data was aggregated in this way, we had enough information to analyze 6,500 crashes in 2018, which is almost half of the crashes that happened that year, distributed in 16,000 kilometers of road in the city of São Paulo. So it's a really high availability of data for us to analyze. So we had the statistical report with 99% degree of statistical confidence, which is really good. And we used various statistical models using, we have, this is really good to say too, we have in our team a data scientist, which is an econometrician, an expert in econometry, sorry. We have also the data team together with the geoprocessing team, the GIS team, and the road safety experts to deal together with the authorities. So we have these three teams, which I think is really important to work together to answer this kind of hypothesis without making any assumptions that we could not do. And we used some models like regressions, logic to beat, two-stage estimation, things like that. So we didn't use AI in this specific study. So the results, we analyzed 5 hypotheses. Our main goal here was not only to answer the hypothesis, but also to foster the culture of using this kind of evidence-based results together, public and private organizations working together with this kind of results. So this is not only a technical result, they are not only technical results, but they are also political results. So here, what I'm going to bring to you is the main indicators. I'm not going to show all the models that we developed. We are preparing a paper which is more for review and discussion to show this kind of model. But here I'm going to show the main results and some disclaimers before that. We don't have data on exposure. We didn't have data on exposure too, as we were saying earlier. We didn't have data on exposure. So we use some proxies or something to use as a surrogate, like the hierarchy of the lane. Here in São Paulo, they are really related to the volume of and the composition of the flow. So use that as a proxy, but this is something that we need to work more here in São Paulo to have this kind of information, this kind of data to improve our analysis. So the first hypothesis, when there is a traffic jam on the road, crashes are more frequent. The results showed that indeed the occurrence of crashes is much higher when there is a traffic jam on the street. And I'm going to highlight the last indicator in the end of the page. We have 22 times more frequent crashes with motorcycles with pedestrians when we have a light traffic jam, and up to 90 times more frequent in heavy traffic jams than in free flow. This is something that is really interesting to see here in Brazil, because we don't have the regulation doesn't say anything about lane splitting, which is the act of driving the motorcyclist is driving between two occupied lanes in the traffic. So they can do that. And we don't have information about how serious this is here, the size of this problem. And with this result, we can show the authorities, like, you should take some care about that, right? The next one, which was not confirmed, was whenever the flow is free, there are more fatal crashes, and there's no evidence to support this hypothesis. And we found this is really interesting because in fact, the occurrence of fatal crashes is greater in moments without traffic jam, but there are other characteristics that has more explainability to the cause of that. So we found correlation, but we didn't find causality. This is really important. So the causality here is more related to road hierarchy, as I said, which is related to flow and volume of the flow and composition of the flow. Time of the day, which is and whole road hierarchy is really related to the speed limit of the road. This is absolutely important. Time of the day, which is related to speed too. We know that at night and dawn, people tend to drive faster, and speed of the free flow, the actual speed observed on the road. So fatal crashes occur above all on arterial roads, high speed, and at night. So next one. The third hypothesis was when the block is longer, vehicles develop higher speeds, and the results of the analysis pointed a direct interference of the curve length in the average practice speed, but the impact is small. And this is really interesting. And for us, this is really important because it's really hard for the authorities to change the length of the block, but it's easier to change the road hierarchy, the number of road lanes, the road lane width, the presence of radars, the presence of bicycle infrastructure, and things like that. So this is something that is a good. We found that as a good thing to show. Fourth one, when the block is longer, the severity of crashes is greater. Here we found there is a correlation, but the causes lies on other characteristics. So the increased number of running overs, like crashes between cars and pedestrians, and the increase of vehicle speeds too. So the relationship between the length of the blocks and fatality occurs through these two effects and not the size of the block itself. The fourth and the third hypothesis, they are connected. The fifth hypothesis, when a crash occurs, the average speed of the road reduces in both directions and for a considerable period of time. It was possible to verify that in all groups tested, and we found the occurrence of crash caused some reduction of speed of the road, including the opposite direction where you had the crash. And when there is a crash, the average speed of the road is up to 32% lower than in the next hour compared to normal days, taking up to 3 hours to normalize. And this is really interesting for us. We found that interesting for the authorities to maybe use it on communication campaigns regarding road safety measures that sometimes are not as popular as we wanted. So this can be really helpful. The sixth, when the speed of both road directions are too different, crashes are more frequent and severe, especially with motorcyclists. And here we are considering when you have two lane directions in one carriageway without division. So the hypothesis considered the possibility of the motorcyclists traveling against the traffic flow when there's a congestion in the way, in the direction where they should be traveling. But there is no evidence to support this hypothesis. There was no enough data to show this as true. And this is good. This is good because there was some ideas of intervention here in São Paulo to deal with this situation, but there was no evidence to support the priority of these interventions. So this kind of, even though this hypothesis is not confirmed, is good for the authorities to prioritize one intervention against the other. So, and the last one, crashes with male drivers tend to be more severe. Here, the hypothesis starts from the assumption that when the male drivers can drive on roads with higher speeds, men tend to be more reckless than women, so getting involved in more severe crashes. And we saw that was true. It was possible to verify probability of a crash being fatal increases by almost 70% when it involves only male individuals. And to deepen and qualify this analysis, we use also the attributes about like male drivers who drives more motorcycles, buses, and trucks, night driving, and driving on roads with higher free flow speed. And in this model, they're almost more up to 80% higher, jumping from 3.8% to 6.8% on the chance of fatality. So I think that's it. I'm going to let some time for the discussion. Thank you.